Now, once we have already described the shape functions in the standard coordinate system x, y with limits 0 to L and 0 to W in the x and y directions respectively, I would now like to switch to a different coordinate system that has already been introduced to you, and it's called the natural coordinate system. So in the natural coordinates, if you remember, I hope you do, then we moved from intervals, so your interval limits moved from a to b, so for example from 0 to L to -1 to +1. That means we tried to make a transformation between two different local coordinate systems. So for example, in this case, if I'm going to consider a standard element, a standard rectangular element, which looks like this, then I will have for my 4 different nodes, so I can write this as I, J, M and N. If I have to move from X and Y from 0 to L and 0 to W, then I can easily write here x is equal to 0 and y is equal to 0. In this case, x is equal to L, y is equal to 0. Here is x is equal to L, y is equal to W, and x is equal to 0, y is equal to W would be my coordinates in the x, y system, as we've already seen before. I'm just rewriting it to make it simple and to fit everything in this slide. Now, the origin that is coinciding with x is equal to y is 0 and y is equal to 0 for the standard coordinate system now changes for the natural coordinate system. That means we can't use this as the origin anymore, so we'll have to make a change. So what we would like to do is we would like to have the origin at the center of the element, where you would have a new coordinate axis, and this would be called a new coordinate axis. I'm going to call it R and S. You can also give it different names as you like. And this point therefore corresponds to R is equal to 0, S is equal to 0. So now in this case, I will have a modified coordinates. Here R will be equal to -1, S will be equal to -1. R will here be equal to equal to 1. Sorry, not minus, and S would be equal to -1. The same way here, X would be equal to, R would be equal to, sorry, it's just confusing to write. R would be equal to 1 and S would be equal to 1. And at the same time, you would have here R is equal to -1 and S is equal to 1. And the reason for that is that in the natural coordinate system, the intervals have now moved from 0 to L and 0 to W to -1 to +1. So the total length is sort of like 2, and you have two different sections, so -1 to +1, while you have in the middle the intersection of the origin. So just as we did for the one-dimensional case, we can see we can do a check for how is X related to R and how is Y related to how is S related to Y, that is. So that means we will be able to write it just as we did for the single degree of freedom system, actually not single degree of freedom system, but one-dimensional system. So we can finally write for transformation, let's say a simple relation between the standard coordinates x, y and natural coordinates Rs will be given as R will be equal to 2 times x by L minus 1, S would be equal to 2 times y by W minus 1. And you can check this also with the previous lectures if you're still confused how it works. It's pretty simple to derive. Now, if we go back to the shape functions that we had already derived here, the n1, nj, nm, and n, then we will be easily able to replace the x by r and y by s to be able to get the shape functions in the natural coordinates. So it's just a matter of replacement. So I'm going to do replacing x by r and y by s in, or well, it should not just be replacing but actually substituting the relation in the shape functions, we will get, I'm going to write it here, ni would now be equal to 1/4 of 1 minus r 1 minus s, nj would be equal to 1 by 4 1 plus r 1 minus s, nm would be equal to 1 by 4 1 plus r 1 plus s, and finally nn would be equal to 1 by 4 1 minus r 1 plus s. Now the same basic rules or properties of shape functions will apply. That means the shape function has a value of 1 when it is evaluated at its own coordinates of nodes I, or what if ni is calculated at I, it's 1 and it's 0 at all the other nodes. However, the values will obviously change in the interior of the element. So these are the derivation of the shape function in the natural coordinate system.